All right, hello, this is Mrs. Delavecchia, and this is a walkthrough of Unit 2A study guide. This is for my students. It is not going to be teaching any new content. We're just going over the study guide. So if you are not in my class and you found the video, you're welcome to see how we work through the problems, but we're not going to actually be explaining anything from start. Okay? So in the first one, we're asking, is this a rigid transformation? So the triangle EFG maps to the triangle VWU. So that's what's important here to notice how these two triangles match up. And so we have EF and VW should be the same length. So EF and VW. All right, well, we notice that EF is 12 and VW is 10, and that is not the same, so therefore this must have changed in some way. It is a rigid transformation, must maintain its size, its shape. It can only move around, flip around, reflect, rotate, but it cannot change size. So the answer would be no. And you can just cite one case, which is that EF and VW are not congruent. Okay. All right, in this one, we're reflecting over the x-axis. So it's a multiple choice, but we will just use one of them to check the reflection and what it should be. So in this case, I'm going to notice that the pre-image Q is 2 away from the x-axis, and this point is also 2 away from the x-axis. So that's good. That is a reflection. This is only 1. That is good. This is 1 and 1. And this one is 4 and 4. So every point is the same distance from the x-axis. It has been reflected. So choice A actually is the choice we need. Alrighty. And we're reflecting triangle ABC across y equals x. So y equals x is our diagonal line that goes through the origin and where y equals x. So it's going to look like that. Now we learned you can just count. It has to be the same distance from the diagonal line. But this is an example where your grid's kind of fuzzy here. And it's not real easy to see on this graph. So I think we're going to do this one by the way we talked about with coordinates. If y equals x, then that reflection, I know I need to swap x and y. And then I need to not change any of the signs. So we're not going to mess with the signs, just swap x and y. So this A point is 3, 7. So if A is 3, 7, then A prime is going to be 7, 3. So 7, 1, 2, 3, right there. So if B is 8, 5, then B prime is going to be 5, 8. And that goes right there. And C is 9, negative 3. So C prime is negative 3, 9. All right, so when we connect these points, we should be reflected over that diagonal line y equals x. And that looks pretty good. You can see that looks like a mirror image. Okay. Number 4, we're going to translate this guy with the vector -4, -2. -4, -2. So that tells me I'm going to go on the x-axis -4, on the y-axis -2. So each point, 1, 2, 3, 4, 1, 2. 1, 2, 3, 4, 1, 2. 1, 2, 3, 4, 1, 2. And 1, 2, 3, 4, 1, 2. So our new image is this one right here. Kind of hard to see. Let me erase some of my scribbles. Okay. So I simply moved over 4 and down 2, and that's what you do with a translation. That's all you have to do. All right, now we need to write the rule for this translation. So we're saying how did it move? It went from t to t prime. So it went I'm going to count my x direction first. 1, 2, 3, 4, 5, 6 squares over to the right, so that's the positive direction. And then 1, 2, 3, 4 squares down, and that's a negative direction. So that's how I want to do that. All right, again, finding the translation. So from 3 to 4, I'm going to go in the x direction, 1, 2, 3. I went to the right 3, so that's a positive direction. And then I went 1, 2, 3 up, and that is also a positive direction. So from figure 3 to 4, I went over 3 and up 3. A 180 rotation. So when we talked about our little cheat sheet notes, we said that 180 is the only one out of those 5 that does not switch x and y, but it does switch both signs. So I'm going to take my point, this point, 2, 2, and that's going to become -2, -2. So right here. All right, now I'm going to take this point, 2, 5. That's going to become -2, -5. Okay, and then the third one, 5, 2, is going to become -5, -2. And this is our rotated around 180 degrees. All right, graph the figure after the rotation around the origin with the vertices of 270. Okay, so we're doing a rotation of 270 degrees basically. So I might just take a glance and see which one looks like it's been rotated 270. We're starting with the black image and going to red. So I know point A is starting here. If it rotates 270, it's got to end up it's got to go here and then back to here. That would be 270. So I'm thinking, without a whole lot of thought, it's probably this one. but let's check it out for sure and not make a guess, okay? So I'm going to take point A. Now, we said with a 270 rotation, that means we're going to swap. So A is -4, 4. So A prime, we're going to swap them. You do that. And then the second one, the Y becomes opposite. So that becomes 4, 4. And 1, 2, 3, 4, 1, 2, 3, 4. That is truly the correct choice. A is not in that spot on any other. So we can eliminate everything else and choose choice C. All right, we're going to do, this is a composite. So we're going to do two things. We're going to first reflect it over, so first off, I'm going to go ahead and make this big. We're going to reflect over Y, and then we're going to rotate 90 degrees. Rotate 90 degrees. All right, so a reflection over Y. That means I'm going to take and see how far away each point is from the Y-axis and put those points on. So this is my first transformation, my reflection, and then from there I'm going to rotate 90. So and we said when it doesn't specify, we're going counterclockwise. So a rotation of 90 degrees, we said, is we're going to swap X and Y. Swap X and Y. And then the first one switches signs. All right, so let's take our first point here. -1, -2. All right, I'm going to swap them. And then the first one switches signs. So this becomes +2. So this point will go to 2, -1. Okay. And next, let's look at this point. We've got -4, -2. We're going to swap them. And then the first one changes signs. So that becomes 2, -4. It's going to go here. All right. Running out of colors here. Let's go. We'll get some pink happening. All right, this one is -4, -4, -4, -4. Well, you swap them, you still get -4, -4, and that's going to be 4, -4. So that guy goes here. And then the last one, get something very different. We'll go purple. Purple was at -1, -4. So we're going to swap it and make it opposite. 4, -1. Okay, so this is our new shape that has been reflected and then rotated. All right, here's another combo. We have a translation along 0, 2, and then reflected over X. All right, well, we'll just let's see if we can make a prediction about which one. Reflected 0. Well, the one I'm probably going to eliminate is this one because the coordinates are all in the same place, so it doesn't look like it has been reflected. And also D looks like it's probably not going to be a choice because A and A prime are both on the same side of X. So it could be, yeah, I doubt it's going to be this one again because A and A are on the same side of the axis. But let's check this one out. Let's actually do it. So we're going to translate this 0, 2. So that means each point is going to go up 2. 0 doesn't move anything X, but up 2. So that's our new A. This is our new B. And this is our new C. And now we need to take these points and reflect them over X. So that is going to get A, the purple A is going to come down here and be A prime. C is not any, it is on the x-axis, so you could say it's 0 away from the x-axis, so we're going to leave it where it's at. And then this point here is 1 away, so we will put that there. So this is the correct choice. All right, so we're going to rotate this and then translate it. So rotate 180 degrees and then do this vector -4, 2. So first job is to rotate 180. All right, 180. So 180 means we're not going to swap. So no swapping, but each one becomes opposite of itself. So let's start with K. K is -4, 6. So it becomes 4, -6. L is -3, 3. So it becomes 3, -3. M, -5. -1, so 5, 1. And J, -6, 2, 6, -2. So this is my rotated image right here. Now I should have labeled each of these as I went along. I didn't. But now we're going to translate it -4, 2. So let's do that. 1, 2, 3, 4, up 2, new point. 1, 2, 3, 4, up 2, new point. 1, 2, 3, 4, up 2, new point. And 1, 2, 3, 4, up 2, new point. So this. Okay, so the next one is a ceiling fan has 8 equal blades, equally spaced blades. Find the angle of rotation that maps one blade onto the adjacent blade. So if that fan is going, when would it look exactly the same as it does? So simply the total rotation is 360 degrees. Divided by 8 blades. So 360 divided by 8. 360 divided by 8 is 45 degrees. Does this figure have rotational symmetry? If so, what are the angles of rotation? So same idea. Rotational symmetry means it's going to look the same when I rotate it a certain degrees. So we can see that this would look the same if for every 90-degree rotation. But to prove it, 360 divided by 4 sides is 90 degrees. So every 90 degrees, this figure will look exactly like itself. Okay, how many lines of symmetry does this figure have? It only has one, and it goes straight through it like that. Any other way, it's going to look different if I try to rotate it, reflect it. And is that it? Wow. All right, so hope that helps. And again, just see me if you have questions. I'll talk to you later. Bye-bye.